In the previous assignment, we developed a syntax analyzer for a subset of the C language. In this assignment, we will construct a symbol table. Symbol tables are data structures that are used by compilers to hold information about source program constructs. The information is collected incrementally by the analysis phase of a compiler and used by the synthesis phase to generate the target code. Entries in the symbol table contain information about an identifier such as its character string, its type, its position in storage, and any other relevant information. Symbol tables typically need to support multiple declarations of the same identifier within a program. Symbol table helps in keeping track of identifiers. It is essential for semantic analysis. It is used for error detection, code generation, and optimization. Each symbol, for example, variable, function, etc., is represented as an entry in the symbol table. Each entry can hold name of the symbol, type of the symbol, scope information, address or location, etc. In this code, if you look at line 1, you will notice the declaration of an integer variable x. For standard variables, we intend to record both the variable's data type and the line number. Similarly, in line 2, another variable y is declared with the same data type character, and we store the variable's data type along with the line number. Now let's decide about which structure will be good for implementing a symbol table. A hash table is often used to efficiently store and retrieve symbols. Hashing allows for constant time lookups by using a hash function on the symbol's name. So now we have come to know that we are going to use hash table for implementing the symbol table. For that, we need to design a hash function for identifying the index number where we will keep the information. Let's say I have a hash function where I am taking the ASCII values of the characters which are present on the lexeme, adding the values and then modding the summation value with the bucket size. Here, bucket size means the length of your hash table. Now, let's use the hash function to identify the index where I will store the information of x. The ASCII value of x is 120. Now, if we mod 120 with 8 as our hash table length was 8, we get that in index 0, the information of x will be stored. As x is a normal variable, we are going to store only the data type and the line number for it in the symbol table. For the second line, we got another identifier y, and now we'll have to store information in the symbol table for this identifier. Just like we did previously, we are going to find out the index number using the hash table, and we'll store the data type and line number on that index. Now there will be different scopes on your code. The term scope by itself refers to a portion of a program that is the scope of one or more declarations. Scopes are important because the same identifier can be declared for different purposes in different parts of a program. Common names like I and X often have multiple uses. So for different scopes, there will be different hash tables. The previous scope table will become the parent of the new scope table. Before initializing the YY_parse method, you need to create the scope table for the initial scope. For that, we are creating a symbol table object, SymTBL, which manages scopes and identifiers. And enter scope function creates a new scope table in the symbol table and passing out log as the argument to log this action. Now you have to design the enter scope function on the symbol table header file, which will receive the outlog as the parameter from the YAK file. Now if we go back to our YAK file, there are three parts in your YAK file. In the definition section, you have to create the symbol table where all the scope tables will be located. After that, you will have to declare other necessary variables here to store necessary information such as current variable type, variable list, function name, return type, function parameters type, parameters name, etc. For example, I have declared var list and param list here. Also, you may need to reinitialize variables if you find an error. For example, I have reinitialized var list and parameter list here. Then comes the second part of your React file, which is the rules and actions part. Here you will have to store information in the symbol table, delete information from the symbol table, print information of the symbol tables, and store necessary information on the variables which you have declared for your convenience, and then using those you will store information in the symbol table. Also to mention that when you are storing normal variable information, store the variable name and data type. For storing the array variables, store the variable name, data type, and array size. Lastly, for function names, store the function name, return type, number of parameters, and types of each parameter. Now remember to find out where the parameters and their types are handled in the grammar. Now let's see what we will have to do in the rules and actions section. You will have to print matching grammar rules and corresponding segments of source code as the previous assignment and total number of lines at the end of the log file. Additionally, print the ID of the new scope table when you are entering a new scope. Print which scope table is being removed from the symbol table when you are exiting a scope. When you exit a scope, print all the scope tables currently present on your symbol table. To print the symbol table, you need to print the scope tables in the order they should appear in the scope stack. For each bucket, print the symbols and relevant informations of the symbols. For example, here you have reached the start state. It says to print all the scope table information of your symbol table. Now, you have three other files to edit beside the YAK file. Let's first talk about the symbol info file. As I have previously mentioned that you have to store different information for different kinds of identifiers. For example, whether it is a function or array or variable, then the return type or the data type of the symbol, etc. You will need to pass that information or edit that information from your React file, which is why along with the declaring necessary attributes, you will have to write get and set method for them too, as their access modifiers are private. Next, on your symbol table header file, you will implement the list of scope tables. The class should have a pointer of scope table type which indicates the current scope table. This class should contain the following functionality. The first one is designing the constructor of the class. Secondly, the enter scope method. Here, you will have to create a new scope table and make it the current one. Also, make the previous current table as its parent scope table. Now, if we discuss in details about how to design this method, you have to go through these features. Firstly, you will have to set the length of your scope table. For example, I have set the length to 10. Also, remember that all the tables should have an unique ID. Now, for creating a new scope table, you will have to create an object of scope table class and pass the full bucket size, unique number, and the parent table information. So, now the new table will become the current scope table and the previous current scope table will become the parent of the new table. Lastly, you will have to print the message that a new symbol table has been created. Likewise, you have to design other methods and the destructor as well. For the exit scope method, you have to remove the current scope table from the symbol table and print that which ID scope table has been removed. Also, there is an insert method. You have to insert a symbol in the current scope table, return true for successful insertion and false otherwise. This should call the insert function of the current scope table. Next, there is a lookup method for searching. Look up a symbol in the symbol table. First, search in the current scope table, then search in its parent scope table, and so on. Return a pointer to the symbol table, symbol info object representing the search symbol. Lastly, the print current scope table method will print the current scope table to log file, and the print all scope table method will print all the scope tables which is currently in the symbol table. The last remaining file is the scope table header file. This class implements a hash table, or you can say scope table. You will need to design a hash function. The hash function will determine the corresponding bucket name the symbol info object will go to. The hash function would be any suitable hash function to your choice. The hash function will take the name of the symbol as input. Don't forget to keep the hash value in the range of the bucket size. You will also need a pointer of scope table type object named parent scope as a member variable so that you can maintain a list of scope tables in the symbol table. Also, give each table a unique ID. You also need to design these methods of the scope table class. The insert method will insert into the symbol table if already not inserted. Return type of this function should be Boolean, indicating whether insertion is successful or not. Lookup method will search the hash table for a particular symbol and will return a symbol info pointer. The delete method will delete an entry from the scope table, return true in case of successful deletion or false otherwise. Lastly, the print method will print the scope table in the log file. You should also write a constructor that takes an integer n as a parameter and allocates n buckets for the hash table. You should also write a destructor to deallocate the memory. Finally, after completing the YAC file, symbol info file, symbol table file, and scope table file, run the script file. Remember to keep all the files in the same folder when running. Thank you.